Chemistry 1. Today's lab we're going to be doing your first titration. I'm pretty sure most of you have titrated before in high school, so this should not be completely new to you. So for today we're going to be doing what is called a back titration. So we're going to be analyzing some aspirin tablets. So what we first have to do is do our first titration with sodium hydroxide to determine the concentration of the sodium hydroxide. And then that data is what we use to compare in the second half of the titration. We're going to analyze the tablets that are dissolved within that sodium hydroxide. So let's just begin. I'll be showing you all the equipment, explaining some common errors that students make as we go through this titration together. So I've collected all my equipment here on the table. And our first step is to pipette 25 ml of the 1 molar sodium hydroxide. So we have a glass pipette here and a pipette filler. Just going to rinse the equipment with some deionized water first. So we dip the tip of the pipette filler inside the solution, and as we roll the barrel up, you can see the liquid moving up the pipette. If you don't get it all the way the first time, you can just pull off. Continue. Now 25 ml should be right where that brown line is. So what we normally do, we go a bit past it so that when you lift, it drops down and that meniscus set right there. So we're going to add that to the standard flask. So this is a standard volumetric flask. We're adding 25 ml of the 1 molar sodium hydroxide, and we're going to dilute that in the standard flask using deionized water. So after we add the 25 ml, we're going to fill the standard flask up to this white line with deionized water. So once that's added, you're good. Usually there's a bit of solution that's left inside the tip. These pipettes come calibrated for that solution that remains there, so don't worry about getting that out. Normally I advise students to just pour deionized water until they get to the neck. Once you get to the neck, then you squirt, get at eye level, and read your meniscus. There. Now this is the most important step that a lot of students they make mistakes on. They forget to mix. So you cap and you invert 4 to 7 times just to make sure that solution is properly mixed and diluted. So we have our standardized solution ready. We now take 25 ml of this solution . going to add that to a conical flask. So we have 25 ml of our dilute sodium hydroxide solution. And now for naphthalene indicator, we have it in some prepared bottles. It comes as a clear liquid. But look closely what happens when we add a few drops of phenolphthalein to this basic solution. Turns the solution this pink color. So when we titrate, we'll know we've reached the end point when this pink color goes back clear. Now to prepare our burette. Here we have a 50 ml burette. So the graduations, they run from 0 at the top down to 50 just about here. Normally when you're using a burette, the first thing you do is you rinse it with some deionized water. Make sure it's working. And then you're going to rinse again with some of the solution that will go in the burette. In this case, we're filling the burette with 0.1 molar hydrochloric acid. So if I just take a little bit of that hydrochloric acid, pour it inside the burette, rinse with some acid. This is weak acid, so it's safe to go down the sink. Very dilute acid. We attach our burette then to a burette clamp that's set up already on a retort stand. Normally want the numbers facing you so you can easily read. Somewhere around your height. And then you want the valve to control on your left hand so that you can stir on your right. We're gonna get a funnel now. Make sure this is closed. So when it's horizontal, it's closed. When it's vertical, it's open. We're gonna hold that there and just fill her up with some 0.1 molar hydrochloric acid. Now I advise students to fill past the 0 mark at first, because then what you want to do is go back and always make sure the tip of the burette is also filled with solution and there's no air bubbles. So we're going to open and close, and there, if you look at the tip is also filled with hydrochloric acid. There's no air bubbles. And we can go back with a plastic pipette now and make sure the top is also filled to the 0 mark. So let's lower it to eye level. And there, it's at 0. So our burette is set up and ready to begin titrating. So what we expect to happen is, while we're adding hydrochloric acid to this pink solution, sodium hydroxide with phenolphthalein indicator, when it reaches the end point, this pink color should disappear and turn clear. A common mistake students make when doing titrations is included that one, the burette. Remember we advise that you rinse your burette and you make sure the tip is filled. And also oftentimes they're titrating and they leave the funnel inside the burette. Always remember to remove the funnel from the top of the burette. While you're titrating, you want to Keep swirling this solution and also ensuring that there's not a lot of splashing. You move closer to the tip, you swirl, and you keep mixing while you're adding, and you monitor the color and not necessarily the volume. Since this is a rough titration, we just want to monitor when the color change occurs. So let's begin. We open the valve, we keep our hands on the valve, and we keep stirring to mix. Keep stirring to mix, and we're looking. You can pause and swirl if you want to, and then continue. And we're going to stop as soon as that pink color disappears. Pause again, keep swirling. Still pink. Still pink. It's a bit clearer, but what we always advise is if you're not sure, you get a white background, you look, and you can see there's still a slight bit of pink color. So you can place that under here, a white tile or just a white piece of paper works. And there, the pink color is gone. Now that we know the end point, we go to the burette and we're going to see where that value stopped. Again, you want to take readings at eye level. Remember, you're reading the burette going down. So right now I can see that it's somewhere between 26 and 27. Now we want the exact value, so we go into eye level and we're going to read, and that should be 26.6. So if I turn this for the camera, and if you zoom in right here, you'll see the value. And we're going to record that as a rough titration. So it took 26.6 cm cubes of 0.1 molar hydrochloric acid to neutralize or dilute sodium hydroxide solution. So now that we have a rough, we're going to refill this burette. Normally if you pass the halfway mark, I advise you to refill the burette. You don't want to continue and then your burette passes the 50 mark, because then that's an error. So you want to refill your burette as long as you pass the halfway mark, just to be safe. So take it up back to 0 with hydrochloric acid. And what I'll now do is our accurate titrations. So when we say accurate, we mean we want to know the exact value at which it changes. So we're going to titrate out some and then we're going to slow down. And then what we want is 2 precise readings. Normally we say within 0.5 cm cubes of each other. But to be safer, I normally tell students we're going to do 2 precise readings within 0.2 cm cubes of each other. So we're going to pipette another 25 ml of this dilute sodium hydroxide solution. Things are faulty. Okay, got it. Add that to a new conical flask. again, 2 to 3 drops. The Naphthalene Indicator. 1, 2, 3. That should work. We have that pink color forming. The red tip is filled, already at the 0 mark. And we begin titrating once more. So now we're gonna run this up to about 22. So we're just gonna run to about 22, and then we'll slow down and start adding drop by drop, just to make sure we don't pass the end point this time for our first accurate reading. 17, 18, 19, 20, 21, 22. So we're gonna pause at 22, and we're just gonna lightly open this valve so we get drop by drop, a steady stream. Now we can maneuver better and not pass the end point and see the exact point at which this thing changes. Right now we're at about 24. Slow down the drops. Oftentimes you can see when you're reaching closer to the end point, like right now, you see it still has a little bit of pink, so about 1 more drop should do. Let's get that final drop, and let's see. Yep, that does it. There goes all the pink. And what value did we stop? Right now we're at 25.5. So 25.5. Record that value as T1. That's our first titration. So remember, that's not the rough, that's our accurate. 25.5 cm cubes of HCl. Now we need 2 accurates that are precise for us to be complete with this lab. So I'll just do 1 more titration, and then I'll get back to you with the results. Okay, so we've just completed our second accurate titration. Let's look at that reading. We got the same exact value again, 25.5. So if you just look there, you should be able to see. Reading at eye level, meniscus, exactly on that 25.5. So we're finished with that first half of the lab. So we know that it takes 25.5 cm cubes of the 0.1 molar hydrochloric acid to neutralize this dilute sodium hydroxide solution. We can now dump this solution, as we'll be using a new solution for the second half of the lab. Now the first thing we do is we have to weigh some aspirin tablets. So we have our scale, a weighing book, and just some normal 325 milligram aspirin tablets. So that is important for you to know. These are 325 milligram aspirin tablets. The brand doesn't matter. So normally I'd say about 4 tablets should work. Okay. For a weighing boat, 0 to scale, out of 4 tablets. And that should put us right within the range we need. So we have 1.57 grams for 4 tablets. 1.55. Just wait for the scale to balance out. Let's put this on so the wind doesn't affect it. Yeah, 1.55 grams for 4 tablets, and again it's 325 milligrams of aspirin per tablet. Now we're going to take those tablets. You don't need to crush them or anything. Add them to a conical flask, and to those tablets we're going to add 25 ml of 1 molar sodium hydroxide. This is the part where a lot of students, they make mistakes. Students tend to not label their solutions. Let's just make sure I have it exact value. Yeah, students tend to not label their solution and they end up hydrolyzing with acid instead of the base. So while that empties, let me just show you a trick that we do to check. Here we have red and blue litmus paper. So normally I'd go around, if students say they made a mistake or they're not sure, you take some red litmus paper, just a piece. Let's say we did not know if this was sodium hydroxide or not. If we just take that litmus and dip it, it should turn blue. So we'll know if a student, they hydrolyzed correctly, or maybe they used acid instead of the sodium hydroxide, or some of them end up hydrolyzing with water instead of adding sodium hydroxide. You notice as soon as we added that sodium hydroxide, the tablets began to dissolve and break apart because these are fairly new tablets. So that it shouldn't take too long to dissolve. Quickly set up a burner. So we're just going to have to warm to ensure that these substances mix and react to completion. Okay, now that we have our flame set up, our solution dissolving, we'll take just a sheet of paper, you roll that several times, get a nice fold on it, put that around the edge lip of the conical flask, and this is what we're going to use to hold and mix this solution. Add 25 ml of water to that solution that we're hydrolyzing. Then we get our folded piece of paper, wrap around, and we're just going to warm. We're not boiling. It doesn't necessarily have to touch the flame. We're just warming it a bit to make sure everything reacts and all that residue tends to dissolve. So we want the tablet to be dissolved, broken up. Shouldn't see any large clumps being left behind. So it should be able to touch this thing. You shouldn't be boiling it, heating it too much. You just want to warm it. Now there are impurities within this tablet, so everything might not dissolve, and that is why you do a percentage composition and error in the end, so that you can know how much of the tablet was impurities and how much of it was actually aspirin. Should be good. Now this solution, we're going to take and we're going to add to the standardizing flask. So we're going to transfer all of this into the flask. And we also want to get all the washings into the flask as well. So we're just going to use a water dispenser just to rinse this and make sure we get almost everything into the flask as well. Again, we're going to fill up to the neck. Make sure those bubbles are gone. And we're going to squirt until we reach the mark inside the neck. So I'll get rid of those bubbles. About there. And as always, you cap, invert several times to mix. Don't forget this step. This is what oftentimes produces faulty results. The results are all over the place. It shows no precision. It's because you didn't mix well. And that solution is ready to be titrated. So we take our pipette filler again. Just rinse it out a bit. We're going to pipette 25 ml of this solution. Add that to a clean conical flask. My bad. And to that, add our 2 to 3 drops of Naphthalene Indicator. We got that pink color again. As always, we ensure that our burette is still to the 0 mark for the first titration. With hydrochloric acid. So we refill our burette with more hydrochloric acid. It's the same 0.1 molar acid, so we can just refill. My pipette. My level. Zero. And we'll do our first rough titration. And boom, we have a color change. Notice this one was much faster because there's less base available. Okay, so we've completed our first rough. And the value we've gotten for that is 11.4 cm cubes. So 11.4 cm cubes, we record that value. Now it's time to do our accurates. Now what I suggest in order to save time, like how we've only used about 11.5 ml, we can just continue. So the starting point for this next titration will be 11.4, and then we'll see what the end point will be. And like I said, we're going to continue from the 11.4. So we want to slow down Since it's around 11, we're going to slow down at about 9 away. So 9 away from here should put us at about 21. So we'll slow down at about 20. So let's run up until 20. We're about there. And we're going to start adding drop by drop, just like we did in the previous half of the lab. Adding drop by drop, waiting to see that exact drop that causes the color change. Almost there, one more drop. Here we go. All clear. And where did we stop? So from 11.4 we went to 21.2. That gives us a value of 9.8. And we're just going to do one more accurate titration to make sure we complete the lab. You can pause. Okay, so we've just completed our second accurate titration. That ended at 31.0. So that gives us another value of 9.8. So that pretty much means we're finished with this titration. That is it for this lab. I will share the data with you at the end of this video. Thank you for joining us. And the rest of the information that you need to collect will be given to you by your instructor.